So we have y equal to sine into x plus 1. So they want us to find the derivative of this equation from the first principle. Now for us to understand this equation, if this one is an xy plane, then maybe you have a curve. This is point P, and then this is point Q. So we can assume that this curve is y equals to sine x plus 1. That is the curve. So at this point, of course at this point, we can have the values of x and y, but at the higher point on the curve, we shall have x plus a small increment in x, and then y plus a small increment in y. Because as you climb the curve, the values of x and the values of y are also increasing. So what we are saying is at point P, at this point, y equals to sine x plus 1. But at point Q, we also need now to consider the increment in x and y. So at point Q, we are going to have now y to y plus a small increment in y equals to sine into x plus a small increment in x, then plus 1. So at this point, at point Q, this is the equation that we are going to have. Now, at this point, we can subtract y from both sides. Subtract y from both sides. So on this side, this is y. So when you subtract this y on this side, you remain with this. Del y equals to, now here we have sine into x plus a small increment in x plus 1 minus sine into x plus 1. So we are subtracting y on both sides. So y sine into x plus 1 is our y. So we subtract on both sides. Now after subtracting this, we know that sine A minus sine B is given by sine A minus sine B is given by 2 cos A plus B over 2 sine A minus B all over 2. Sine A minus sine B equals to 2 cos A plus B sine A plus minus B all over 2. Therefore, we can apply this concept for us to be able to get the expression for that. So if that is the case, then we can say this, so that if we apply that, then we shall say that our A will be equal to the x plus del x plus 1, that is our A. Then our B will be equal to x plus 1. And then we apply, so we shall say now, therefore, sine x del x plus 1 minus sine into x plus 1 will be equal to, now apply that concept, it will be equal to 2 cos into A plus B. Our A is this, our B is this, so we have x plus del x plus 1 plus x plus 1. We are adding A plus B. We add them, then all over 2 then sine into a minus b. Remember our a is x plus this, then minus that. So we shall have x plus del x plus 1 minus x minus 1, then all over 2, then all over 2. So when we simplify that, we have here when we simplify that, so remember this was our dy. Our dy will be equal to, now this will be 2 cos into, now we have 2x, also we have 2 into x plus 1 plus del x over 2 like that. We have 2 there. Then sine, then we shall have del x over 2, So these 2 and this one will cancel, so that we have this equals 2 cos into x plus 1, then plus del x over 2 sine del x all over 2. All over 2. Now, so at this point, of course, these 2 will cancel with that 2, so that we have cos into x plus 1 plus del x over 2, then sine del x. Now we have this the concept that we need for the limiting value of sine theta. Limiting value of sine theta over theta when theta approaches 0 is equals to 1. Limiting value of sine theta over theta when theta approaches 0 is equals to 1. So is equals to 1. Therefore, at this point, we divide both sides by del x, so that we have del y over del x will be equal to cos into x plus 1 plus del x all over 2, then sine del x all over del x. We are dividing through by del x like that. By del x. Now, the limiting value of sine theta when theta approaches 0, the limiting value of sine theta over sine theta will be equal to 1. Therefore, if we apply that concept, then this when now x, when theta approaches 0, so this will approach to 1, then sine theta all over the theta will approach 1. Therefore, we have then y del x equals to cos into x plus 1 plus del x all over 2. Now, in the process when del x approaches 0, then the y del x will approach dy dx, it will approach dy dx. Therefore, in that process, we shall have dy dx will be equal to cos into x plus 1, because now this one will be 0. And that's what we have as a result. Thank you for watching and listening.